to present the result of the due work for the project management certificate for Coursera. So the theme I chose is for a headquarter office, having buildings, and it wants to optimize the heat and cooling usage as also the cleaning process in a flex office desk. As a first step, I'm going to clarify the business opportunity definition through the first criteria. Is there a problem? Yes. The opportunities related to the reduction of the cost of the usage of a building. The problem is an adaptation and adequation between the usage of heat or cooling system that could generate extra costs in energy in general for the building, and especially about the unused spaces. Also, the additional unnecessary costs during the day for the unused space, they are also cleaned where they were not used. So why this opportunity is interesting? Because the goal is to, let's say, optimize the use of energy, as also to minimize the number of interventions for cleaning the building. So both cost optimizations can be the result of this solution. Also, rather than having, let's say, more or less a fixed cost for the building on a monthly basis, integrating optimization means potentially reducing the average monthly cost, that is having a cost evolving all along the year, but at a lower level. The usage of machine learning is also interesting, as by focusing on energy consumption, is also possible to automatize the energy management in the building and control the systems, tuning the heat cooling level, and also considering all the historical data. It's possible to compare and to find correlations between the people occupancy in the building, as also the level of consumption, and also identify trends that could be used then for predicting the potential energy volume needed, depending on the number of people present in the building. For the third criteria of this business opportunity, so the main people who care about this kind of solution to this problem is mainly the facility manager, who has the responsibility of optimizing the cost of the building. So this kind of solution could be a big help for him to perform the tracking, to adapt, let's say, the building behavior and minimize the cost. Also, if we look at the company level, this could be also a mean to detect, in case of really low occupancy, to see what are the buildings owned by the company who are less used, maybe not used at all. And so this could lead to decision to close some offices. As a second point now, let's consider the business understanding, especially in relation with a CRISP-DM model. So for the problem definition, as say the target user is a facility manager, the problem statement is how to optimize the building costs regarding energy and cleaning interventions. Why it matters, so in order to reduce the monthly cost of the building, also to adapt the cleaning strategy of the building and limit duration and number of interventions, and also to support and develop, let's say, a sustainable corporate social responsibility. Another interesting point is that it could also provide some information about the new spaces in the building and maybe lead to decision to reduce the building size to rent. How it is solved today? So most of the time there is energy control, but only based on a day or night period of time. It does not include the number of people in the management of the energy. And for building cleaning, there is no strategy yet. The only one is that at fixed frequency, so twice per week or three times per week, all the building is cleaned. The gap regarding the current state and the solution is that employee presence in building is not considered yet, and the space usage is not measured, that is detected. So from now, no cleaning strategy can be developed. About the success definition, if we look at the potential business impact, if we consider a FlexOffice approach with 70% of the surface available for 100% of employees, if the company has 50% of employees working from home, it means that 20% minimum of the surface is potentially unused. So it means that this cost could be optimized. Regarding the constraints, there are needs to have specific inputs. So a few systems are not yet available, like the number of employees during the day, the space used or unused. They need to consider the weather condition, as also to look at how the cleaning company is open for on-demand cleaning intervention strategy. Also regarding the counting of people or the use of space, there are some consideration about GDPR and the fact that nobody's has to be identifiable thanks to this counting solution. And there is also the need to get the predictions 1 week before the next cleaning slots organization. If we look at how these impacts translate into metrics, so for the business outcomes, that's the optimization, that is a limitation of cleaning intervention, having them faster with cheaper cost, and masterizing the energy consumption thanks to an overall reduction strategy adapted to the real usage of the building. For the associated metrics, we can consider the evolution of the monthly energy bill, the evolution of the cleaning bill, as also the employee satisfaction rate about the working conditions. That is, if there is a good alignment between the feeling of the employees and the heat or cooling level in the building. On model side and or solution side, the outputs are more the mid-square results of space prediction to measure, let's say, if our model is performant enough, and about the metrics, the mean square must be lower than a predefined rate to be sure that we are encountering the right level of expectations. The interesting factors are the number of employees each day, as also they are spread over the building, that is in which space they are working or which space they are traveling, as also weather, as also to be considered, especially about the temperature related to energy consumption, as also the conditions like rain or snow, especially to anticipate the cleaning needs if there are, let's say, more pregnant or not. For the validation plan development, so the usage of machine learning in the proposed solution, it will be on collecting the data about electricity consumptions, cleaning intervention schedule, duration, weather forecast, people counting and presence detection. Once the email gathered all of these inputs, we can train a model to be able to predict, considering these inputs, the spaces to be used in order to limit energy consumption, as also what would be the temperature or the heat conditions to maintain in the building, depending on the level of people. The facility manager will have a global prediction in order that he can reduce or increase the number of cleaning intervention or the level of heat or cooling to be used for the keeping the living condition in the building. Solution concepts, validation proposal. So for this, the machine learning model will be trained on the historical data month by month. So for each month, a prediction is done for the next month. So first set of data on a monthly basis is used to train the model. So then once the model is validated, the next step is to consider the next month of historical data, to process it with the model, to check what are the results and check if, let's say, the results from the previous training is okay or not, and if not, if improvements are possible. In this case, we perform an optimization of the model, and we continue this iterative process to enrich and tune our model in terms of performances. So this can be done, for example, on a 6-month period, depending on the availability of the data. And each time the model is applied on a new month, adaptation is done or on it to improve the performances. So once all month data have been used, the model is deployed to process the real data. So no more the historical data. And in this case, there will be interactions with customer to adapt and to understand if the predictions are matching the customer expectations. So the main key decision about machine learning system conceptions, as the use case is to provide lots of data, and this can come also from different sources, like energy providers, external energy providers. In this case, the cloud approach is preferred. Also with a cloud approach, as the data storage need to be huge and can highly increase over the time, the cloud elasticity is well adapted for this approach. Regarding the learning and the training, there is no need for the initial problem to perform retraining as soon as new data are available. So the model retraining can be done once or twice per day. This is at the fixed frequency. In this case, the offline learning is the best approach. About the predictions, they do not need to be also done in real time or for each new data received. We can plan this at a fixed frequency. So we can consider to perform all the predictions to be used as batch predictions. So this approach is a good one to be considered. The potential risk identification and prediction model. So one of the potential risks is about the training or service queue. Data history can be quite different in terms of volume. It can be, or depending on sources. For example, for energy consumption, it's quite easy to have a global set of and huge set of data. Whereas for the new system, for other sources like the space usage or the people counting, the new subsystem need to be deployed, so there won't be a lot of history. So the model has to deal with this short history, and so prediction would be not exactly the one in production. Regarding latency, there is no impact. For the data drift, in case of the remote work that is employing working from home, in case this strategy is changed by the company by reducing the number of possible days, this may have a huge impact on the use of the building with more and more people present at the office. So there will be consequently an immediate increase of people on site. This would mean that we could notice a big, let's say, usage of the spaces, no more spaces, as also an increasing number of cleaning rotations to plan. In the concept drift, so the cost reduction is defined considering a flex office level plus a specific work from home policy of the company. If there is any change of this policy, this may directly impact the model that has been implemented, and so the predictions can also derive as the context of its use changes. Thank you for your attention.